In this section, we are looking at the last part after the collection of which might be incorporated during the collection of the gas. Very often, right, the gases that we are trying to collect could be wet because they originated from maybe a solution, or they have been made to pass through water. Okay, so we may not want to collect a wet gas, and therefore drying the gas becomes an essential procedure which we need to uh, incorporate, okay, during our collection of gas. Okay, but how do we go about drying gases? Okay, so for drying of gases, okay, we will need the help of something called a drying agent. Okay, so this drying agent is responsible, is like kind of like a helper, right? It helps us to dry the gas. But there are three drying agents in your syllabus known as concentrated sulfuric acid. Okay, we also have calcium oxide, also known as quicklime. There we also have calcium chloride as well, okay, or they call it fused calcium chloride. Okay, but I don't want to add too many words, otherwise you get very overwhelmed. So sulfuric acid, calcium oxide, and calcium chloride. Okay, so the question is, when do we use which drying agent, right? Do not randomly choose them. It all depends on the nature of the gas that you are trying to dry. Okay, what do I mean by nature? So this is probably a new word to you. The nature of the gas is the gas acidic? Is the gas alkaline? Or is the gas neutral? Okay, so not to worry, at this point in time, you are definitely not equipped to know which gas is acidic, which gas is alkaline, which gas is neutral. So the question will definitely give you the necessary information. Okay, so I'm going to be showing you every single case. Okay, so let's take a look. Now, if the gas that you're trying to collect is this, okay, if the gas that you're trying to collect is generally acidic, all right, then you should use concentrated sulfuric acid. Okay, so you can actually insert this word. So if the gas that you're collecting is acidic, like hydrogen chloride or chlorine, etc., right, you will actually use concentrated sulfuric acid. That is the part which you need to remember. Okay, so how does it work? Let me show you. So you have an acidic gas. You will then bubble it through a delivery tube into a container of concentrated sulfuric acid, which is my drying agent. Okay, so while passing through sulfuric acid, the sulfuric acid will absorb the water from the gas, and then the bubbles of gas that escape will now be dry. Okay, then you get your dry gas. So it's as simple as that. Okay, but I want to draw your attention to two things. Okay, I don't know whether you notice that the delivery tube length are not the same. Okay, the first delivery tube, which is showing the acidic moist gas, actually introducing the gas into concentrated sulfuric acid, this particular one, okay, it has to be a longer delivery tube such that the gas goes into the drying agent. Okay, because you need the gas to be in contact with the drying agent, then only the drying agent will be able to do its job. Okay, but for the second delivery tube on the right hand side, you want to collect gases that has already been dried and they have escaped from the surface of the liquid of the drying agent. So it should be a shorter delivery tube. Okay, so it will just be collecting gases which are in this region and then into another apparatus to collect your gas. Okay, so that is how our first drying agent works. Okay, now one thing to take note, you need to ensure that you never ever use concentrated sulfuric acid for gases which are alkaline. Okay, that's a big no-no, because something that is acidic, which you will learn in future very quickly, and something that is alkaline, they will react with each other. So the last thing you want would be, while drying, your sulfuric acid starts to react with the gas, and then you have no more gas at the end. Okay, it's kind of like you're trying to dry yourself with a towel. Your towel is just there to absorb water. But can you imagine, while you're drying yourself with the towel reacts with you. Like, for example, part of the towel gets stuck onto your body permanently. Okay, you wouldn't want that to happen. Okay, so that is what we mean. That is the reason why. That is also the reason why, when you have concentrated sulfuric acid, which is actually acidic in nature, you use it to dry acidic gas. Okay, same kind, they are not going to react. Acid and acid, they will not react. Okay, so that is for drying agent number 1. Next, the next drying agent is called calcium oxide. Okay, a little bit of background about calcium oxide. Calcium oxide is actually alkaline in nature. So it will be very good for drying alkaline gases. Top number 1 will be ammonia. Okay, so it's very good for drying alkaline gases. Okay, very bad for drying acidic gases. Okay, so very bad choice. All right, so yeah, that's about it, to be aware of it. So you need to remember that calcium oxide is actually alkaline. Then it's easier for you to deduce what kind of gases it can dry. Okay, the third drying agent is called calcium chloride. Okay, now calcium chloride is actually ranging from slightly acidic to neutral. So I would prefer you to actually just remember, it's more, I would say it will tend towards neutral. So what is it good for drying? It will be good for drying neutral gases, such as nitrogen, hydrogen, and maybe a little bit of acidic gas like carbon dioxide. But your alkaline gases are definitely a big no-no. Okay, alkaline gases will be a big no-no. So that is fused calcium chloride. So you are expected to remember each of them. Okay, and if I were to provide you with a quick summary, so we have concentrated sulfuric acid, which is acidic, so it will dry acidic gas. Okay, then we have calcium oxide. You must memorize, it's alkaline, so it's good for drying alkaline gas. Okay, calcium chloride, the last one which we just saw, I would say it tends to be neutral, so it is good for drying neutral gas. Okay, or slightly acidic gas, because it's slightly acidic to neutral. Okay, so that's about it. And if you turn your page, you will see a link for you to actually watch the video on the 3 methods of collection of gases, okay, that you have learned previously. So I will leave you to actually watch the video on your own. I have also attached it in your SLS as well. Okay, now we are going to complete the last activity on page 8, whereby we are going to draw an experimental setup, okay, using all the skills that we have learned, to show how a gas can be collected via gas streams or displacement of water. Okay, I'm going to show you both. Now, the reason why I'm teaching you this is because, right, about 2-3 years ago, this question came out during one of the practical exam for pure science. Okay, so it will be good for you to actually start early and practice on your drawing. Okay, now Miss Mok is actually also not an artist, okay, by birth. I'm very bad at my drawing. Okay, but if I can do this, I'm very sure all of you can do it as well. Okay, but ideally, of course, you are drawing a scientific diagram, you should be using ruler. Okay, it's kind of difficult for me to do it on the iPad right now, so I'm going to draw freehand. So it's actually more challenging for me, drawing freehand, but you can use a ruler to do. Okay, so let's do this together. Okay, if anytime I'm too fast, you just pause the video. Okay, you can take your time. All right, so it's very simple. First, to draw the collection of gas via a gas syringe, okay, you must start off with a apparatus whereby there's a reaction that produces a gas. Okay, so with the apparatus that I will use for this reaction to actually take place is a conical flask. Okay, to draw a conical flask, you just need to draw two short lines and a long line. Okay, a long horizontal line like this, so it looks like a poker face, right? Okay, so that is the beginning. Then you connect them. Okay, and then you get a conical flask. Okay, let me adjust a little bit. Okay, so you get a conical flask. So of course, please draw in using ruler, okay, for all of you. Yeah, then after which I'm going to start drawing the delivery tube. So you draw two vertical lines, but the one on the left is slightly shorter at the top. Okay, after which you draw two horizontal lines. So you can see there's a delivery tube that is coming up. Okay, then there's a connector. So you draw something like a rectangular or squarish shape. This connector connects it to a gas syringe. So let's start drawing a gas syringe. Okay, of course my diagram is not drawn to scale. So I'm just showing you how the method is being, how is it carried out. So vertical lines, first, two vertical lines. Then you draw two horizontal lines. Simple, you're just drawing lines only. One vertical line. Okay, do not touch the two sides. Two horizontal lines, which are longer than the two lines outside. Two vertical lines. Two short horizontal lines. And one vertical line to connect. Okay, so what you have just drawn is the plunger of the gas syringe. Okay, but you cannot have the barrel that is actually open and then the gas is escaping, right? So you just do a final touch up, close up the gap. So you have your plunger and you have your barrel for the gas syringe. Okay, but we are going to collect the gas and we are going to measure the volume of the gas. So your gas syringe cannot have no markings, right? So therefore, you draw four short lines followed by followed by one longer line, another four, and the fifth one is a long line, four, fifth one like this. So it looks quite professional already, right? Okay, you have a gas syringe there. Then what do? Close this gap up with four horizontal lines. This is actually your gas syringe. Label your diagram. This is actually your delivery tube. Okay, with rubber bunk. But of course, there was a reaction somewhere. So maybe there was a liquid and it was reacting with some solid. Okay, I'm going to give you the names of the substances, but you don't panic. Okay, because you do not know why is these two substances as of now. So you just take my word for it. Okay, so let's say we have a hydrochloric acid here. And maybe we have some calcium carbonate. Okay, and the two of them actually produce a gas called carbon dioxide, which we can collect via the gas syringe. So can you see that it's actually a very simple drawing? Okay, just ensure that you know how to draw lines and label. Okay, so how do we replicate this diagram, right, to show displacement of water? Okay, it's actually very simple. The only thing is you are going to be changing this whole section, okay, the gas syringe, into displacement of water. So the earlier part remains exactly the same. Okay, so let me just push this up and show you. So I'm going to draw my conical flask again. Okay, let me just redraw this. The shape is quite awkward. Okay, then we have our two vertical lines, horizontal line, my square, and then two horizontal lines. Okay, technically speaking, at this point, we will actually attach it to a gas change earlier on, right? But now I need to bubble it into a setup which shows displacement of water. Okay, so before you start drawing anything here, okay, you should draw the displacement of water portion. So my suggestion is you can start drawing a large trough of water here. Okay, then after that you have a container. Now this container can be called a gas jar, or you can simply use, which I'm going to draw now, an inverted measuring cylinder. Okay, if you use a gas jar with no marking, you can only collect the gas. You cannot measure the volume of the gas. But if you use a container, a measuring cylinder, you can actually read off the value lah, as in the volume of gas collected. Okay, after which, what do? Okay, you just need to, okay, you watch how I do it. You extend this line, bring it down, and then bring it up. Okay, then you do the same for the other line. Okay, you should draw all these using ruler. Okay, my diagram is not as good because I'm not using ruler. Okay, so can you see how I extend the delivery tube? Okay, then after which, it's very simple. You just need to make fine adjustment. You ensure that the examiners know that you are doing displacement of water. Oh, okay, give me a moment. Okay, you shouldn't have a line here. Alright, so this is the water level in the trough. Okay, but here maybe your water level is like this. Then if you want, you can add on the bubbles just to show. Okay, then this is all the water. Okay, yep. So now with that done, it's time for us to label, right? Okay, so just make sure this part is closed up. Then once again, you have your solid and your liquid. So this is a measuring cylinder. And if you want to show that you can measure the volume of the gas, right, you can add in the markings. 4 short, 1 long is the standard way I use. 4 short, 1 long, 4 short, 1 long. Okay, so that's the measuring cylinder, and this is the delivery tube. And this is the hydrochloric acid, calcium carbonate. All right, so I hope that this is helpful to you in terms of the drawing of the two experimental setup. Okay, so you take your time to draw. Okay, and once you're done, you can actually just take some time to complete page 9 and 10 of your notes. But if you struggle with page 9 and 10, right, it's perfectly fine. Okay, you come back to class, we'll discuss it together. These questions are not totally all simple because I did not actually go through it with you. So we will iron out all these issues in class. Okay, so this is the concludes the end of part 1 of chapter 1. There's still a part 2 where you'll be learning about separation techniques. Okay, so just to do a final review of what we have covered today. Okay, this is our learning objective. Okay, so we have already covered physical quantities, and then we have looked at apparatus. Okay, and I gave a very detailed discussion about all these apparatus. Then we also look at collection of gases via the four methods, okay, and drying of gas involving a drying agent, and you see drying agent includes only these three, but you must know the nature of what kind of gases will be suitable to be dried by which drying agent.